All right, 4.7, finally done with this chapter. We're going to talk about a different form called point slope form, which is highlighted here. So let's talk about the other forms we have really quickly. So just as a review, we have slope intercept form, which is y equals mx plus b. Standard form, which is some number times x plus some number times y is equal to some letter, or some number, and that's standard form. So this one gives me my slope and the y-intercept. This one helps me find x and y-intercepts by, if I want the y-intercept, I make the x coefficient 0. If I want the x-intercept, I make the y 0, and then solve for the other variable to figure out that. So this is great for finding intercepts. This one's kind of the most standard if you know the y-intercept. So point slope form is probably the most versatile because all I need is a point and the slope. So however I get that, I can get the slope sometimes from two points, but I only actually need one of the points along with the slope, or 2 points that I can find the slope, and we'll talk about that in a second. So the form is y, which is one of the numbers that you can put in there. This y stays, and then it passes through a point x, y. So either one of these, they used this point for example. So this x value went here, this y value went here. Don't worry, we'll explain it further. So it's y minus y1 is equal to the slope times x minus x1, where y1 and x1 are basically points on the line that you know of. So here we have, it would just be set up as y, and then the value of y in my point is 1, so y minus 1 is equal to my slope, which is 2/3, and then x minus this x value is -6, so minus and -6 would be +6, and I'm done. So this would be point slope form for this particular example. Okay, so the two reasons to use point slope form are, one, you're given a point, you only have one point on the line and the slope. The other one is if you're given 2 points, but one of those points is not the y-intercept. So for instance, this -2, 4, and 5, 6. So in the prior chapter where we were doing this, or in the prior section, there was always one of them that would be like 0, 5, or 0, -2, or something like that, which is the y-intercept. So if I don't have this, and I only have 2 points, I can solve it. So let's look at that. So what if I have these 2 points? Okay, so I'm going to solve for it. So first thing I'm going to do is I'm going to write y minus y1 is equal to m times x minus x1, because I'm trying to memorize this formula, so you're going to want to do this on each one. But step 1 is actually to find my slope, because it didn't tell me the slope on this one. So m is equal to the change in y, so y2 minus y1 over x2 minus x1. And that's going to be equal to, well, let's see, I'm going to start with this one, so I'm going to make this y2 and this x, therefore this is x2. So I'm going to go 4, and then my y1 will be -2, so 4 minus a -2 is +2, and that's going to be over 2 minus 5. So that gives me 6 over -3, or -2. -2 over 1, -2. So back to my original equation. I would have done this on away from this thing. So I end up with, now I can pick So I'm going to go y minus something is equal to my slope, which is -2, times x minus something. Okay, and what is the y? So it doesn't matter which one of these 2 points I use. You would get the same thing if you simplified it. So y minus, I'll just use this first one, 2, 4. So the y value is 4, the x value is 2. Remember, if either one of those was negative, it would become plus. And then what I can do is, once I have this, now I can solve for the slope-intercept. So I can distribute here. So y minus 4 is equal to -2x plus 4. I just distributed the -2. And then I can add 4 here. And y will be equal to -2x. And then I added 4 here, plus 8. And so from point slope, I can easily transition to slope-intercept form. So that's another reason why this is a really cool one. Okay, so how do I use that in real life? So you're going to parasail and you begin pulling back to the boat. After 2 seconds, you are 25 feet above the boat. At what height were you parasailing? So we're here and we're being pulled back into the boat. So we started maybe up here somewhere and we're going down. So we're going to have a negative slope and we're going down at 10 feet per second. Now hopefully you recognize that this is a rate and therefore it is our slope. So let's see here. So what do we know? So we're going to use y minus y1 is equal to the slope times x minus x1. And what are our points here? You finish parasailing and being pulled back to the boat after 2 seconds. So which one is a dependent and independent variables here? Which one's y and which one's x? Pause the video if you can and try to think of it. So hopefully you realize that time, the amount of time is going to determine how far above the boat we are. And the longer we go, the closer to the boat we're going to get. So this is our y and this is our x. It's important that you guys get that. If you don't, come see me. So y minus 25 is equal to my slope, which is 10. Actually, it'd be -10 because we're going down. And then x minus 2. So I have this point 2, 25, right? That was one of my points. And I was given the slope, which is right here. And then this would be the point slope form, and then if I wanted to distribute here and then solve for y, I could also do that. And then you could graph the whole thing. All right, so hopefully, oh, and then it asks what height were you parasailing? In other words, what is the y-intercept? So we would need to solve, so let's do that. Y minus 25 is equal to -10x plus 20. So now we add 25 to both sides. And it looks like we were parasailing at, so we were going down -10 at 45 feet. Because this, in slope-intercept, is my y-intercept, and that's where I started. All right, have a good one, guys. See you next time.